Hi, in this video, we're going to look at subnetting again. This time we're going to look a little bit more at the bits, and actually we're going to see that actually makes things a little easier. Okay, you've seen this before. An IPv4 address, 32 bits. We have to borrow from that subnet, from the host portion to create the subnets. Okay. Now, when subnetting on a natural octet boundary, /8 to a /16 or /16 to a /24, that makes it a little easier to do. But when we're subnetting within the natural octet, that requires us to usually look at the bits. And we're going to see this in more detail in the next video. But I just want to kind of introduce us to that right now. Excuse me. So remember our customer from the previous video was allocated the 10.4.0.0/16 network address. Okay. And let's say our customer wants to actually subnet, create its own subnetworks within its organization. Okay, again, it can't touch the network portion, the first 16 bits. That belongs to the ISP, to the provider. Okay, so it has to borrow from the host portion to create its own subnets. So this enterprise is going to borrow 8 bits from its host portion, extending its subnet mask from a /16 to a /24. Okay, so this will allow the enterprise to create smaller networks. Okay, and again, it's borrowing from the host portion. It's going to borrow 8 bits. This changes the subnet mask from 255.255.0.0 to 255.255.255.0 from a /16 to a /24. Okay, the enterprise will now have control of those 8 network bits, sometimes known as the subnet bits, to create the subnets. Okay, let's take a look. Okay, so going from extending that subnet mask from /16 to /24, we're using that third octet where we're subnetting on a natural octet boundary going from /16 to /24. We're going to use that for the network, for the subnet. Okay, so the first 2 octets, the 10 and the 4, don't change. Can't change those because those belong to the provider. But we're extending that by 8 bits from /16 to /24 to create our subnets. And we can see we go from 0, 1, 2, 3, 4, 5, and keep on going all the way to 254, 255. Okay, that's our 256 subnets using those 8 bits in the subnet portion of the prefix length, the overall network portion of the address. All right, so what about our previous host? Remember that host that had the 10.4.16.16 address in the previous video? Okay, when it had a /16 mask, it was part of a larger network. Okay, we can see the network address has all zeros in the host portion, the first host all zeros and a 1, the last host all 1s and a 0, and the broadcast all 1s. And there were the addresses, including the network address, first host, last host, and broadcast for that network. Okay, but when we decided to extend the mask to a /24, 255, 255, 255.0, what we've done is we actually extended the network portion. So let's take a look in binary what these look like. So the network address for this host, okay, is now, we just copy all these network from this bit all the way to here to this last line because it's 255, 255, 255. It's a /24. So we're going to copy all 24 of those bits here. Okay, so this is the network address, and we put all zeros in the host portion for the network address. The first host is going to have the same first 24 bits, but in the host portion is going to be all zeros and a 1. The last host, the first 24 bits, why 24? That's our mask, our new subnet mask that we decided on, 255, 255, 255. Okay, /24. So the network portion for this subnet, they're all going to share the same first 24 bits. The network address, first host, last host, and broadcast. Okay. So we can actually see what those are. So now our host belongs to not the 10.4.0.0/16 network, but now that we've subnetted and changed its mask, the device's mask to a /24, it now belongs to the 10.4.16.0/24 subnet. The first host in this subnet is 10.4.16.1, the last host 10.4.16.254, and the broadcast 10.4.16.255. And we can see that our host at 10.4.16.66 is in that range between 1 and 254. Okay, so this was our host information, what subnet it belongs to, and information on that subnet was the first host, last host, and broadcast of that subnet. But let's look at the other subnets. So first of all, for this subnet, for all these subnets, they're going to have 8 bits in the host portion. So that means we're going to have 2 to the 8th minus 2, which gives us 250 hosts per subnet. Now the number of subnet bits, the subnet bits is between what our previous network was, which was a /16 allocated to us by our ISP /16, and what we borrowed. So we borrowed 8 bits to create this subnet. So the subnet bits are 8 bits. That allows us to figure out 2 to the 8th bits gives us 256 subnets. So we can figure out how many subnets we have, each one with 254 hosts. What do those subnet addresses look like? Well, all we have to do is in this subnet portion between these two lines, start with all zeros. That's our first network address, 10.4.0.0. This is a /24. The first 24 bits are the network portion. And we just increment that by 1. We just keep on counting all the way till we get all ones in the subnet portion. And we can see where we get our subnet 0 to 255 in that third octet. It was by incrementing those bits. Okay, so what does our network look like? Well, now we can have this enterprise can now have different /24 subnets. Okay. Notice there's host A in the 10.4.16 0/24 subnet with the /24 mask 255, 255, 255, 0. So its default gateway is going to be an IP address on that subnet, 10.4.16.1. We've allocated the first host address for this subnet to be the default gateway, the router's IPv4 address. Okay. We can see we've done that for all of our subnets. Now we decided to subnet. That had nothing to do with our provider. Our provider still sees us as 10.4.0.0/16. There you can see it in the routing table. Okay, so they're going to forward anything with the first 16 bits of the destination IPv4 address being 10.4 to us. How we allocate, how we subnet, or whether or not we subnet or not is totally up to us. But it's our responsibility once the ISP forwards that packet, those packets to router R1, it's our responsibility as the network administrator to be able to configure the routers and the networks properly so the packets are forwarded to their proper destination and reach there successfully. Okay, so let's just kind of look at what we had and what we did. So at the top here is the organization before we subnetted. Down below is what it looks like after we subnetted. So PCA has the same IPv4 address in both cases. What's different is the subnet mask. It was a /16, now it became a /24. Also, a different default gateway address. Okay? The default gateway address has to be an IPv4 address on that subnet. And what we've done is allocated the first address of that subnet to be the default gateway address. Okay, the 10.4.16.100, when the host was 10.4.16.100, it was a device that PCA was a host with just another host with 65,634 other possible devices, right? One large network. When it became a host on the smaller subnet, okay, it's a host with 254 possible devices. Okay, so we've actually made it a smaller broadcast domain. So an ARP request down here, okay, is going to be contained within this subnet. At a maximum, 254 devices would see the broadcast, the ARP request. Up here, though, everybody in this network would see the ARP request, which would be a possible 65,534 devices. Okay, so as far as configuring the router, notice that I haven't not showing any of the static or dynamic routing configuration, but notice that each router's interface is a member of that subnet. Okay, so I'm just showing router R1 here. Okay. All right. I hope this makes sense to you. And we'll be talking much more about this in later videos.